Good morning, everybody, and welcome to our fourth electric reliability presentation. And some points of order here in case you have any. There's restrooms are through the back door here from the room, make an immediate right and then a left. Should the need to evacuate arise, I understand from the proprietors here that we can bring up those shades on the west side here and go directly out those doors onto the patio area. That'll be the collecting area in case of an evacuation. So, also for those that are attending via Skype, my moderator Madison is logged into the system here, and she'll be taking any questions via chat. And we do plan to take those questions at the end of the presentation and give you the answers at that point. So, otherwise, the audio from the audience via Skype is muted. I think that's correct. Okay, very good. Okay, well, again, welcome everybody. Thanks for attending. And Mr. Steve? Oh, yeah. We're going to be very fortunate at the end of my presentation to hear from one of our company's meteorologists, Steve Vandenberg, and he's going to provide us some useful perspectives on weather as it impacts our system from a reliability standpoint. So that'll be good to have as an augmentation. Anyways, without any further ado, we'll provide a high-level description today of how the electric system works, how reliability gets measured. We'll discuss the various active programs that the company sponsors in the interest of continually improving its reliability of service for the customers. We'll take a look at some comparisons with the other California investor-owned utilities and share some of the details from the formal annual report, which is posted at our company's intranet site, sdge.com. And just as a point of review, or perhaps new information for those of you that may not be familiar, the electric grid is evolving. It's evolving from a very vertically integrated orientation with large generation plants, transmission, distribution, to one that's moving more towards a distributed energy type of architecture. For example, the net energy metering, largely the solar net energy metering projects that customers decide to put on their properties. That's now totaled over 1,150 megawatts of net nameplate capacity on customers' properties spread out through our territory. So that's just an example of the more distributed nature of generation that's coming online. But for the most part, the grid is still vertically integrated to a large extent in consisting of large blocks of renewable as well as conventional resources such as natural gas-fired power plants. Often these are located at some distance from where the customers reside, so the high voltage transmission lines are used to span those long distances, bring in large bulk amounts of power measured in oftentimes in the hundreds or thousands of megawatts into the larger community. Substations transform that energy to a lower voltage that can be then safely distributed through the neighborhoods. And finally, we have line transformers that are in the neighborhoods to step the voltage down to its final utilization value, which is generally something between 120 and 200 and 240 volts for general residential, single-phase, three-phase commercial use. The entire system is built and operated with the ultimate goal of providing safe, reliable, clean operation. But most of our reliability events do tend to happen on the distribution side of the equation. The amount of exposure to faults is much greater on the distribution side. The distribution circuits go into the neighborhoods and the communities where the customers are, so that's generally where we see most of the outage events occur. Probably in the earlier days of the industry, outages due to generation problems were more common, and I think our company's last generation-related outage goes back to the 1950s. So we generally categorize outages as either due to transmission or substation or distribution-related causes. We really haven't seen generation be a factor, so they aren't really tracked. Generation-related outages are not tracked as a specific category. Okay, so you might say, how is reliability measured throughout the industry? Are there some industry standard measurements that generally, at least through North America, if not the world, that are agreed upon? And indeed there are. And along with our goal to provide our customers with safe, reliable, and clean power, We also want to make sure that we have an objective measurement so we can compare ourselves. It's important to compare ourselves to our peers in the industry, other utilities in the state, other utilities across North America. So there are several of these reliability-centered measurements that are used throughout the industry. The first two that you see here are the Sadie and the SAIFI index. That's the System Average Interruption Duration Index, Sadie. And then you have the System Average Interruption Frequency Index. That's the SAIFI. We call it SAIFI. The first one is a measurement of the average duration of outages to a customer on a system. And the second one is a measurement of how often customers experience an outage that's greater than 5 minutes. Okay, an outage on our system that's less than 5 minutes of duration, we consider that to be a MAFI, or a momentary outage. And you see that noted here in towards one of the bottom bullets. There's also another index called CAIDI. That's the Customer Average Interruption Duration Index. And that's basically Sadie divided by SAIFI. That's another value that we track for the purpose of comparing ourselves primarily to other companies, but also comparing within our operating districts. We have 6 of them, and they're arranged geographically. We want to compare performance across our different operating districts, while at the same time we recognize they have different challenges, of course, be it coastal environment or rural, urban, and so forth. So we gather these over the course of a year. Theoretically, we would start at 12 a.m. on New Year's morning with a 0 number for both of those. If there aren't any outages right at the time, then when the first outage hits in the new year, we start to accumulate values for both Sadie and SAIFI. Those are the 2 measurements we primarily focus on, but we actually do gather information on all of these. In addition, we have the so-called Major Event Day, or we call it a MED. And a Major Event Day is a recognized, when the outages in a given day have exceeded a certain threshold that's figured mathematically, then that's considered to be outside the norm of what we would tend to want to operate in system and plan the system and engineer the system to try to tolerate. So a major event day could be a major Santa Ana event with high winds that extend over a number of days, or it could be a typical winter storm that comes in perhaps with mass quantities of rain and lightning. And we don't generally see that kind of weather here in San Diego, so the system's not expected to perform particularly well in those conditions. But we do track those days as they're important to how we manage the data and see how we're doing. The major event day usually represents, by the time the math is done, about 1% of the outages, and those are the very worst outages that we have. And you'll see some examples of that. All of these measures are derived from the IEEE standard 1366. The IEEE is the Institute of Electrical and Electronic Engineers. It's a internationally recognized organization of engineers from those disciplines, the electrical and the electronic disciplines. And they have a large voice in helping us to set up these universal standards. They're actually worldwide standards. So to talk a little bit about our reliability programs here at SDG&E, some examples are the fire risk mitigation. We call it FIRM for short, fire risk mitigation. And we have a very robust vegetation management in which we actually inventory all of the trees that are along our various rights of way. Not only are the trees inventoried, but we also inventory them by species. And we're able to, but by virtue of the fact we have qualified foresters from that discipline on staff, we're able to determine what the applicable trim rate should be. How frequent does this particular tree need to be trimmed to ensure that it stays clear of the lines and it does not become a factor for us. We've also been recognized by the National Arbor Day program in 16 years in a row. And our program, our vegetation management program, has been recognized officially by the CPUC as a model for other operators to follow. So suffice to say, there's many programs underway that impact our reliability in a positive way. As you can see here, the FIRM program aims to improve the performance of the overhead lines in fire-prone rural areas, thereby lowering the risk and optimizing reliability. We're replacing wood poles with steel poles. Steel poles are going to tolerate fires in a much more benign manner than a wood pole. We also have, as I mentioned, the effective vegetation management program with over 460,000 trees that are inventory. That's nearly 500,000 trees that we track in a database so that we know when each one of them needs to be, is due for trimming. There's also the so-called PRIME program. PRIME stands for Pole Risk Mitigation and Engineering, PRIME. And the main objective is that, of the PRIME program is to evaluate all the poles in the system using contemporary analysis tools that are computer-based, different tools and technologies. We want to make sure we confirm that all the poles in our system, and I believe there's about 250,000 poles that are used in the system, both transmission, distribution, confirm that they meet or exceed our standards in the company for strength. A question? Mm-hmm. Sure. So a question from Tom, I believe? Yes. So a question from our audience here in the room about undergrounding as a strategy for managing the risk of wildfire, if I understand that correctly. And indeed, we do have programs that are just now getting underway to do very strategic undergrounding. As you can imagine, undergrounding would be the most expensive option as compared to work on the overhead. But in some cases, that's the best option. And you may have an overhead line that goes cross-country over hill and dale. It doesn't follow any roads because it doesn't have to. When we do an underground conversion project, it does have to follow at least a dirt road. So that oftentimes results in maybe a line that's right now 3 miles long. When you underground it, now it's going to be 6 miles long because it has to follow the road. Yeah, so we have the traditional, the so-called Rule 20A conversions, and within the city of San Diego, there's the Rule 20 SD programs, and these are programs that are aimed not so much at necessarily managing fire risk, but they're aimed at converting lines that are in the vicinity of a large group of customers. So they're more aimed at the urban areas. The city of San Diego has a very robust program that includes both the 20A program, which has been around since the late 60s, and the so-called 20SD or block conversion program. And I believe that program has been around for about 10 years now. Those combined, again, within the city of San Diego, actually have doubled the rate of conversions within that boundary. So the way that works out, and you mentioned the communications providers, AT&T and Cox, we generally give them the opportunity to go what's known as joint trench with our projects, and there is a cost to them to do that, but it's generally going to be less than if they were to do it on their own. We give them the opportunity, and it's up to those providers to join us if they want to. They can put in copper lines, they can put in coax, or they can put in fiber optic. That's really up to them. The Coxes, the Spectrums, the AT&Ts of the world. So there are some measures. Yes. Mm-hmm. One other question. Yeah, when did you come up with this tree trimming? Oh, tree trimming, if I recall, goes back to 1998 when it became a codified program under the auspices of the PUC. Prior to that, we had a tree trimming program, but it was not as formal a program as we have today. Yes, and I can speak from experience. I remember the time before it became as formal as it is now, and indeed we had a lot more tree contact outages back earlier. We're in a dry state. Absolutely, we're in a dry state, and the dry weather will tend to retard the growth of the trees. We're always happy to see rain, but along with the rain comes increased growth over the next few months, and that can be a challenge to keep up with. One other question.
Yeah, it's the same as his, but I was just going to ask, are they going through street to street to look to see where the line is going on the poles? I mean, like you were saying, tree trimming, will be going to neighborhoods and their yards
Yes.
Will there be trimming inside there? Because I know there's a lot of trimming we need to do.
Yeah, and by all means, if you as customers are aware of what you think might be a hazard, call the company. It's 1-800-411-SDG&E. Feel free to report what you think may be a tree problem if you become aware of that, if you think it might be a problem. Yeah, absolutely.
It doesn't have to be on the street. It can be on the lines of the back of your
Anywhere,
car, right?
yes. Yeah, and I think the kind of construction the kind of construction you're talking about, we call it backlot line, and it was installed many decades ago. You may or may not even have an alley, but the distribution lines go right between the properties. Those can be a challenge. And by all means, if you see what you think might be a problem, report it and we'll check it out.
Okay, then, because I noticed now, since the PG&E is having that problem over there, now they're going to neighborhoods and cutting and giving the permission of the owners to, if they can cut their trees or not, or they can cut it,
Yeah,
for free.
yeah, this is free of cost.
If we're doing the same thing here.
Yeah, we are, and it's free of cost to the property owner. In fact, I understand they generally try to, if a tree is in a position such that as it continues to grow, it's going to be a constant problem, it's going to be a constant threat to the line, we'll try to get permission to remove it. And I think sometimes we provide either suggestions or maybe we even provide a possible substitute tree that would not grow as fast or be a threat. So by all means, call us and you'll find out about those programs. Yeah, good question. Any other questions? All right, so these are just some examples of our reliability programs. The FIRM program in particular, that's the Fire Risk Mitigation Program, has completed about 26% of the work that's required for the 1,500 circuit miles. 1,500 circuit miles, so that would stretch from here to probably well into Kansas if you were to have it all linear. So we've covered about 390 of the circuit miles that we intend to cover under the FIRM program. And I understand from talking to one of the project managers there just this morning that that program is continuing to ramp up, possibly to a maximum plateau of about 4,000 spans per year. And an average span is 250 feet in our system. So you can kind of do the math and get an idea of the magnitude. It is significant. Prime Pole Risk Mitigation Engineering until last week was a pilot program. Now it's official. It was a part of our GRC approval that came through late last week in our 2019 and 2021 general rate case decision from the Utilities Commission. All right. Some additional examples of reliability program. We have one that we call T Modernization, and no, it doesn't have anything to do with golfing. It has to do with a particular type of connector that's used on our larger underground cables to electrically bolt the cables together to have good conductivity. We've learned over the years these particular components can be troublesome as they go through their service life, so we have a program that's specific to addressing that issue and making it better. One program that's near and dear to my heart, the SCADA program, that's the Supervisory Control and Data Acquisition, that provides direct operator access to over 2,000 switches across the entire 4,100 square mile network. And so through the SCADA system, we're able to do a number of control tasks that were previously required dispatching a lineman with a truck. We can now do them within a matter of minutes of the need. So we might have an outage on a major feeder, 2,000, 3,000 customers might be out of power. We don't necessarily know the cause just yet, but through SCADA we can get maybe 1,500 of those customers back up and running within 5 or 10 minutes. So it's really become a very useful tool for us, the SCADA system. We have also our business services project coordination, which conducts customer outreach and outage notifications. I would encourage you to go to our app. I believe we have the app both for iOS and Android phones that gives you real-time updates on outages in terms of the customer counts and the duration of the outages, or I should say when the outage is expected to be concluded. And that's useful information really for any of our customers to have. All right. And continuing with our reliability programs, we'll hear some more from Mr. Vandenberg about our meteorology program, but I would put our meteorology staff up against any others in the world in terms of being able to accurately forecast what's going to happen with the weather. It's uncanny how close they come, especially for the Santa Anas. And they can tell you just about down to the minute where the winds are going to pick up and to what extent the winds will go sustained, and to what extent you'll have gusts above those steady wind programs, those steady wind values. We have a proactive cable replacement program. Basically, nothing we install is going to last forever. Underground cable, underground distribution cable, we generally are counting on a 35 to 40-year service life. So cables that were installed back in the late 70s and the mid to early 80s, now they're coming up due for renewal. We would like to get to those before they do fail and cause an unplanned outage. And so this proactive cable replacement program is aimed at just that, identifying the cables that are nearing the end of their service life. Maybe they're a particular kind of construction that we know has become troublesome over the decades. We've become pretty good at finding those and get them replaced on a planned basis with less customer impact. Maybe in some cases no customer impact, but oftentimes there's at least a planned outage, and at least customers are able to prepare for that. We have other aging infrastructure in addition to cables. Substation upgrades are done to address the end of service life for substations, which again, that's maybe in the 40 to 50 year time frame. Lower voltage distribution circuits that were installed many years ago are often upgraded to higher voltage, and what I'm talking about there is generally the older neighborhoods in the urban areas generally were served from older 4 kV circuits. Now we like to upgrade those to 12 kV, get much more capacity, much better voltage regulation from doing that. Okay. And moving along here, some additional examples. We have switches that also have gone through a significant part of their service life. They have become inoperative. We call them DOE, do not operate energized. And we have a program aimed at either replacing or removing those switches that have reached the end of their service life. This better facilitates quicker restoration by our crews because they're able to operate those switches directly without having a concern for employee or public safety. We do our best that we can to reduce vehicle contacts with equipment. It's no secret, you know, now and then we have large trucks or passenger cars run into poles, run into pad mount equipment, and cause an outage. If we have an opportunity in an area to relocate a piece of major equipment so that it's not so at risk of a vehicle contact, we'll do that. But to be honest, we do that pretty sparsely because of the cost and the benefit is difficult to measure. Mylar balloons, so-called party balloons that you can buy at Party City or any one of a number of other outlets, they are very conductive. And if they get up into the overhead lines or even into one of our substations, they can cause a rather spectacular outage. So this is a problem that came up on our industry probably in a big way 10 or 15 years ago. And at some point several years ago, somebody in the company had an idea that, well, maybe we can work with the balloon industry, the party balloon industry, to develop a less conductive or a non-conductive alternative to these balloons. It still has the ability to be produced in the same format as the traditional balloons. It can still have the decorative print, you know, it might say congrats graduate or happy birthday or happy wedding or whatever. They'll still look and feel and act like a regular party balloon, but it won't be conductive. And indeed, we've done some tests earlier this year with some prototypes of these new party balloons, or I should say party balloons made of this new material, and they've performed quite well up to some fairly high voltages, and so the outlook for that is quite promising. The way that might roll out would be as manufacturers choose to continue to do business in a state-by-state basis. I would see individual states having legislative action that would require by legislation that after a certain date, all balloons sold in the state have to be made of a non-conductive material, because it will be a real option. And I would look forward to that coming online probably in the next 2 to 3 years. We'll get a handle on that problem. In fact, just yesterday we had a fairly major outage in the North County area due to Mylar balloon. So they can be significant. Some reliability accomplishments. Reliability is something that we're very proud of here at the company, and so when there are opportunities to go for recognition, we take full use of those opportunities. We've been selected as best in the West by PA Consulting for 14 consecutive years. PA Consulting is a leader in utilities and energy consultation. We've received also Best in the Nation for 2017. It was awarded to us in 2018, Best in the Nation. We also received a Technology and Innovation Award in 2016-2017. Edison Electric Institute, that's one of the large organizations of investor-owned utilities in the United States. We received the 2018 Edison Award from that institution. And we were also recognized by the California Public Utilities Commission in 2016 as the best investor-owned utility in California. So it was good to see that recognition from our regulator. All right. And so we can't talk about reliability without comparing to ourselves to our sister utilities in the state. That's Southern California Edison, Pacific Gas and Electric. We often compare ourselves to them because they operate in a similar regulatory and customer environment as we do. You know, we all share the same state, so we think it's meaningful to do that. Okay, so this bar chart has been updated to provide a 5-year Sadie reliability index view for the 3 big utilities, ourselves, Southern Cal Edison, and PG&E. PG&E is shown in red, SCE is shown in green, and SDG&E is shown in blue. And you can see throughout the 5-year time, our Sadie Index has been generally the best of all 3 of the big utilities, except in 2018. We got bumped into second place by our colleagues up there at SCE. So we certainly aim to get back to first place and be able to have that superior performance. But PG&E has typically been the outlier, although you can see that's changing now with Edison. Some years coming out either very even with PG&E or actually having a higher Sadie index. And you remember the Sadie index is the duration index. It's the amount of minutes per year that the average customer finds themselves without service. So that's the Sadie index. The next comparison is for the SAFE index. That's the frequency index, also going back 5 years. And it's getting the same color coding here. And for 2018, as you can see, PG&E had a higher number is a worst performance, so PG&E struggled the most. And then thankfully, SDG&E came in the best, but we were very closely, we had SCE on our heels at 0.72 on the frequency index. We came in 0.63. Again, that's the SAFE index, the frequency. Question, yes? Yeah, so there's an observation from the audience that seems to be a pattern where it alternates up and down and up and down. And it can be a number of reasons for that. We have years here in San Diego where we really don't have many weather events. Or maybe we just have 1 or 2 Santa Anas, and maybe those Santa Anas are fairly modest. And then we'll go into a year that starts out very wet. And it's not so much the rain necessarily that is an impact, it's the rain and wind together that can cause a problem. And maybe in that same year we also have a significant number of Santa Anas with higher winds. So it really is weather dependent. It's a good observation though. Okay, in the annual report that's posted on our website, sdge.com, you'll see that broken down into 9 sections, and you can see those all related here. Specifically, it's sdge.com/system-reliability. sdge.com/system-reliability. And again, you'll see these 9 sections when you go there. Okay, giving a view here on section 1. This is just an excerpt from the posted report. These are the system indices for the past 10 years. So going from 2018 back to 2009, you can see the variation. On the left side, we've got the major event days included. Those are the exceptional days with large segments of customers out for a significant duration, such as you might have during a Santa Ana with high winds, or such as you might have during a significant wintertime rainstorm. Does anybody notice the number for 2011, the Sadie index for 2011? Why that's so high? Anybody live here in 2011? Specifically September of 2011, September 8th. 2011, we had the system-wide outage, and it started at 3:38 in the afternoon. Yeah, so some recognition there in the audience. And I believe we had it wrapped up within 12 hours, which was significant, that we were able to recover from a total system outage in about a half a day. So if you're going to include, and obviously that was a major event day, what we call a med day, so that does get included on the tally on the left-hand side, the 567 minutes. Most of that was driven by that one event, that outage event. On the right-hand side of this chart, you see the outage indices with the MED, the major event days, excluded, and you see the event of that is to take the indices to a narrower bandwidth and try to account for the type of events that we can design and engineer and operate and try to minimize. So that's the difference between these two charts. And again, you'll see this in the report if you look it up. Section 2 takes those indices and breaks it down into individual districts. Again, as I mentioned, we have 6 operating districts. The district that we are in here now in El Cajon is part of our eastern operating district. And so this is an example. Table 2-2 is a breakdown of the results, the reliability results for that district, for eastern district. And so if you were to go in to look at the report, you would see some variations as a function of the different challenges of the different districts. Our northeast district is geographically the largest. So they have mountain, they have some suburban, and they have some urban exposure in, say, for instance, the Poway, Rancho Bernardo, Escondido area as compared to Palomar Mountain and Warner Springs. Then you have the Beach Cities district, which handles the beach communities. Geographically the most compact, but also from an electrical load standpoint has the highest amount of load in it. So that's the Beach Cities district. But what you see here in the presentation is for Eastern. And you can see all the districts in the formal report. All right. Going back 10 years, the system and district indices going back 10 years, including planned outages. And this provides an excerpt of that. Again, I look at the Sadie, the duration, the SAFE, the frequency, the customer average interruption duration index, the CADI, as well as the momentary index, the MAFE. Those are all shown here for sake of looking at the long-term performance over a decade, basically, is what you have here. You can see in this chart the effects of the weather episodes that we had in 2017 and 2018 and how they impacted our performance as compared to other years. So that's section 3. All right. Our service territory, as shown by this map, we cover probably 99.5% of San Diego County. There is a very small sliver of the county in the far northeast that's covered by another utility. And we cover roughly the bottom 1/3 of Orange County, basically the southern Orange County, up to, as you drive north on Interstate 5, you go up to, I believe, around the La Paz off-ramp. That's about where the division is between ourselves and Southern California Edison. Altogether, we have about 4,100 square miles that we're responsible for, which would be akin to the Big Island of Hawaii. It's about the same size in terms of square miles. And the different colors you see on this map show the different operating districts. And as you can tell, the yellow in the northeast, that's the northeast district, it's the largest, followed by the eastern district, where we are right now, is more of an orange color there to the bottom right-hand corner. All right. So one other thing that we tend to want to look at is which circuits are getting hit the most frequency, with the most frequent outages. We call those the so-called worst performing circuits, or WPC. In this particular chart, it is excluding the major event days, and you see a lot of circuits here represented from the eastern and the northeast district. There is only one circuit outside that group from the metro region. It's one of the downtown circuits called CE1 that's become troublesome because a lot of the equipment is reaching the end of its service life. We do have a program in place to get that equipment renewed, but as is the case with any downtown circuit, you can see it's 100% underground, and that generally makes the work a little more challenging than it would be if it was a mix of overhead and underground. So that's worst performing circuits. That's the top 1% of our worst performing circuits in the system, WPC. Section 6 from the report discusses the top 10 major unplanned outages. So we also call those so-called forced outages, unplanned outages within the reporting year. And this is a summary based on customer impact. And you see the worst case was in mid-November of 2018, with almost 36,000 customers impacted. That was one of our Santa Ana red flag warning days, where we had, in addition to the forced outages that possibly due to other causes, maybe on the underground, because underground systems don't know that there's a Santa Ana, you know, they're going to have a problem, they'll have a problem. But many of these outages in mid-November were due to the need to shut off customers for public safety. So that's what you see the impact there from. Again, Section 6, top 10 major unplanned outages for the reporting year. Section 7 takes the major event days and breaks it down actually by hour, the number of customers that we had out for that event. And this particular event, like the one I was just talking about, it looks at November the 12th, 2018, which was a continuation of that Santa Ana red flag warning event. And you can tell from looking at this chart that things really got going with nearly 7,200 customers out as of, I believe that's 8 in the morning. And this actually goes every 2 hours and provides a tally of the customers out. And so the numbers increased throughout the day as the event progressed, and then they started to trail off, and we had this event wrapped up in approximately, if I see that, I'll call it 88 hours after it started. So you can see how many days that covered, that particular red flag warning event, and that was a significant one for us. Okay, so that's Section 7. That's a summary of major event day actions. Okay. Section 8 shows the historical 10 largest unplanned outages over the last 10 years, and this is an excerpt that takes us at least back to 2018. And you can see the outage in terms of the date that it occurred, the ranking, the duration index, that's the Sadie, and the frequency index, the SAFE, as well as a description of the cause. And you can see causes such here is high wind events. We had a substation problem in January 31st. We had a lightning storm come through, one of the few lightning storms we see around here, October 12th. So everything is listed here as far as the cause factors for these large unplanned outages. And that was Section 8. So Section 9 shows you resources that you can use as customers for making inquiries or maybe getting information on outages. And as I said before, sdge.com/system-reliability, or you can use the SDGE app for Android and iOS, and you go onto the app, you'll have a button on there for outages, and you see that it'll give you a real-time update. If there are no outages, you'll simply see a map of the service area, and there won't be any pins on it. But generally, almost any time of day, any day of the week, there's an outage somewhere that we are responding to. We do have a robust social media program, including Twitter, Facebook, Pinterest, YouTube, and LinkedIn, that can be leveraged as a channel to contact us. We have all these channels that can be used to let us know or ask us a question or bring a concern forth. We don't want to have any roadblocks to customer communications, so we have those all available for us and our customers. And there's beyond that, there's even additional customer engagement channels, email, direct mail, a contact center. You can go through our public relations group. You can text us, use social media, live chat. There's a number of different channels for getting hold of us and sharing your concern or having a question answered. All right. Outage tools for customers. There's a video that's posted on sdge.com that talks about how outages occur, what causes them, and what our response typically is for those outages. Some examples of the different outage maps that you would see online, and then as well in the lower left-hand corner, the outage map that you would see in a mobile format. It's pretty easy to read. I use it quite often, actually, if I'm out and about and I hear about something going on. Classification of assets, we talked about that. So generally our assets are either transmission, distribution, or substation. Again, the generating plants are an asset for us, but they don't generally become a factor for outages. We talked about reliability indices. We talked about the Sadie duration, the SAFE, the frequency index, Katie, Mayfie, and the major event days. We talked about some of our reliability efforts, such as firm, vegetation management, all the data gathering and circuit analysis work that we do. We'll hear from Steve here shortly about the meteorology program, and we made some comparisons with the other two large IOUs in the state. And further on, again, we have our 2018 annual report posted, both on sdge.com as well as the CPUC's website, and we have all these other customer engagement channels that are open to us. So I would encourage you as customers to take advantage of that when you have the need. Any other questions? Yes, sir. Oh, so the question from the audience is, are we going to merge with another company? And I'm flattered to think you think that I would know about that. There may be plans to merge with some other utility, and I'm not at a level where I would know about that.
I see some of these places where they have
Wind turbines, yes.
is that going to be a thing?
So the question from the audience, are wind turbines going to be a thing? And I would say they're already a thing. And I would see more going to being built by developer companies. We call these merchant plants. I don't believe any of the wind farms you see in our territory are owned and operated by SDG&E as a regulated utility. They're operated by merchant operators. They send that power, they dispatch it into the California state grid, and then they make money that way. The other option around here is solar, and I see solar plants continuing to be put in both by customers under the net energy metering tariff, as well as merchant plants, the so-called sale for resale, that are generally very large. Customers have options. Yes, absolutely. You mentioned batteries, and batteries are right now still fairly nascent, but they're going to be coming online, I think, in a big way. We already have probably over 100 megawatts net of battery capacity on our system, and there's more coming online every year. Yeah. Yes?
I'm sorry, it was a great presentation.
Thank you.
I didn't keep your name and position.
Yes, thank you. I don't think I offered it earlier. Michael Colburn. Michael Colburn, and I'm a construction operations manager for SDG&E.
Well, I actually did have a question.
Yeah.
This may not be relevant to your presentation. We could take it offline.
Sure.
Some other people here may not be interested, but very briefly, most of the things you're talking about, which there's quite a bit there, are outages that are planned or unplanned, but and in the distribution section. But transmission, as California grows and population gets much higher, it seems to me that during the very hot days, the load on the transmission facilities I don't know exactly where you buy it all or how it's all acquired.
Mm-hmm.
Over the last few years, I don't believe there's been any outages due to excessive load on the system that I know of. But this has been talked about years ago. Maybe this is not an issue anymore.
Yes.
Could you briefly maybe address that, or should we talk about it later?
Sure. I can address it in a summary fashion here. So I believe the question was, what about the growth in the state and its impact on the loading of the transmission system? We call that the bulk power system. And outages due to overloads on the transmission lines are exceedingly rare. The California ISO does an exceptional job of planning ahead, not just one day, but many days in the future, and ensuring that the facilities are in service so that we can withstand an unplanned loss of a major facility and not have any customers impacted. And that's why it generally is not an issue so much. We call that the so-called N-1 criteria. You should be able to lose the largest single asset on your network and not have any impact to customers.
Okay, thank you.
And apparently it works.
Can you give a brief synopsis of why we had load shed in the past, the early 2000s, versus why that's not an issue now?
Sure. So some of you were around for the energy crisis around 2000, 2001, and there was some unusual practices underway in terms of generating plants, and we actually did get into a supply issue because of that. And so in those days, some of you may remember seeing that the utilities were having to do what's known as load curtailment. And load curtailment is generally something you know might be a threat 2 or 3 days ahead, and you are then able to say, all right, there's this factor called spinning reserve, which means the amount of megawatts between your supply, the generation, and the demand that's from the customers is getting too close together, and to avoid losing the entire system because of an instability problem, we have to plan and shave off maybe 50 or 100 or 200 megawatts in the middle of the day generally is when it would happen. So that hasn't happened for probably now 15 or 17 years since we had load curtailments. And so is that a threat in the future? I doubt it. I think there's been so much new generation come online in the meantime, and the problems that became apparent with the energy crisis of 2000, those have been resolved now in a regulatory manner. In some ways, we kind of stepped back as a state back into a more regulated regime as it relates to that, and I don't think we'll see that again. But it's always a possibility. Yes. Yes. Yes, it does.
So we need to turn on something.
Yeah.
Is that going to be 4 to 9 for good, or is it just for the summer?
Yeah, so a couple questions from the audience here regarding the 4 to 9 relatively high price region for the time of use customers, which I believe over the next few months more and more customers are going to be put on that time of use rate. And is that ever going to change in the future? It could change possibly if more storage resources are brought online to help mitigate the issue of why the peak tends to happen from 4 to 9. Used to be our system would peak out in September or August, sometime in the early afternoon. 1:30 to 2:30, maybe 3 in the afternoon, we'd have a peak demand. And once we got through that, we were good, and we didn't have to implore our customers to conserve so much necessarily. Now in the world of renewables, primarily in this part of the world, solar, what happens around 4 or 5 o'clock? Well, the sun goes down, and so the solar output goes down. Customers come home. The customers are interested in watching the news on TV, maybe cooking their dinner, what have you. So there's a natural uptick in the electric demand, and that now has become the major issue that taxes the system, not just SDG&E, but across the entire state. Now, if we get a lot more energy storage installed to where it can help ride through that high demand time from 4 to 9, maybe that doesn't become so much of a concern. But obviously right now it is a challenge for customers, especially in the summertime, because I think the rate goes up well north of 55 cents a kilowatt hour. So I think what the company is saying with that is don't change your entire lifestyle because of that. If you need to cook, cook your meal. If you're going to watch a show, watch a show. But if you can defer things like running a dishwasher, if you have a dishwasher, or your clothes, or especially electric dryer, an electric dryer will pull a lot of power from the grid. If you can do that after 9 or before 4, then you'll come out ahead.
Our company has heard a lot of concerns about that 4 to 9 time period and the impacts on customers with air conditioning and how hot it gets and things like that. So we are looking at different rate options for the future, but right now there's nothing I don't think on the table where we can share with you guys yet. But
Yeah.
We have heard that concern, and I know our customer service department is concerned about that.
And the other, so there's an observation from the audience that the company is looking at options for customers to help address this issue, because obviously the vast majority of our working customers, that's the time they come home, and what are they going to do? Sit in the dark until 9 and then do everything? Probably not. Probably not. So the other thing I think has come along is a desire on the part of the company to not have this such a seasonal change in rates. Because it's adding to the what's termed as rate shock bill impact to customers by having this seasonal increase in the rate on the summertime, and so there's a filing I believe we've made with the commission to just have it be level throughout the entire year.
So people with solar, are they going to be penalized or something?
Yeah, so the question, will people with solar be penalized? And I've heard that observation before, and I don't believe that's going to be the case. Yeah.
Hey, Mike, from a strictly customer point of view,
Mm-hmm.
a lot of these projects, solar projects or maybe increased installation of batteries, require approval from SDG&E or Commission to Operate or something like that. It would be very helpful if there was some process in place to make it more convenient to schedule the approval process, the appointments, which would be convenient for both the customer and SDG&E.
So a question about approvals of solar and battery installations by SDG&E and scheduling the visits for those.
Yes, by individual owners or commercial. Or
Okay. And these are specific to what we call the net energy metering, typically the solar panels that people put on their homes?
Yes, and the visit that's required to approve that
Okay.
installation and there being a more convenient process for people to schedule when that
Okay.
visit should take place.
So I can speak with some authority on that. Are we good on time?
It's 11:55, so
Okay.
we should probably start wrapping up.
Okay, I'll answer this question and then I'll have to yield to Steve, but
We'll be around afterwards, so we
yeah.
can hang on.
Yeah, but I can speak with some authority on that because about a year ago, I installed my own solar system, and we have a so-called fast-track approval process where either you as a property owner, if you're doing it yourself, or more likely it's a contractor that's doing it, all they have to do is take a digital image of certain aspects of the installation, email it to our customer generation group, and they can approve the system generally within a day or two. So I can share some more information with you on that. Okay? I'd like to invite Mr. Steve Vandenberg, Principal Meteorologist. I have that right? And he'll say a few words about the work that he does. And thank you. Thank you, everybody.